Chapter 4 is going to start talking about congruent figures, and in particular we'll talk about congruent triangles. So the first thing we're going to do in this first section is talk about congruent polygons and their corresponding parts. So if I have congruent polygons, then their corresponding parts, which are the matching sides and angles, are going to be congruent. So whenever you're talking about corresponding sides, you have to make sure that you're matching up the correct vertex with the correct vertex on the corresponding part. So meaning, when it talks about AB being congruent to EF, A is the corresponding angle with E, B is the corresponding angle with F, C is the corresponding angle with G, and then D is corresponding with H. So notice in how they wrote that out that those vertices match up, and that's very important because then you can tell from the statement what angles match up. You also have to do the same thing when you match up the sides. So AB would be congruent to EF, and notice that A and E match up and B and F match up. So be very particular on how you write this. So let's take a look at an example. In this statement, HIJK is congruent to LMNO. What are the congruent corresponding parts? They give you a statement, they also give you a picture. So if you wanted to, you could try in your mind visualizing, rotating, and possibly flipping this. So flip this over and then rotate it a little bit so that these would lie up on the same thing. So if you were to pick this up and move it over here, they would have the same shape. So if you can't visualize that, it might work best for you just to look at the statement. So that's how I do it. If I'm going to name all of the corresponding sides or angles, my first step is I just do the angles. So the first letter in this polygon is going to match up with the first letter in this. So that's how I know H and L are going to be congruent. The second letters will match up as corresponding parts. So I and M will be congruent. Angles J and N will be congruent, and K and O will be congruent. So I don't necessarily use the picture, I use the statement because it's a lot quicker and it doesn't take me as less time to figure out what to do here. For corresponding parts, I always have to match the angles and the sides. So then I would take the first two letters, which is HI, and match it up with the first two letters over here. So HI corresponds to LM. IJ, the second and the third, will match up with MN, which is the second and the third. J and K matches up with N and O, and then I'm going to wrap around. So I'm going to do K and H, so the last and the first matches this set over here, which would be O and O. So corresponding parts, it is very important how you write them out because the corresponding angle has to match on every single piece. Alright, go ahead and take a look at the got it question and try that. So in the got it question, they don't give you a picture, they just give you a statement. So you would want to work it through the same way that I did the previous. So angle W matches up with M because they're the first letters, Y and K, and S and V. Then I would do my side, so I would match up the first two with the first two here. So WY matches with MK. The second and the third, YS matches with KV. And then last I did WS, so the first and the last, so over here. S and W, so then that means over here I have to do V and M. So once again, very important how you line those up because they have to be listing and corresponding vertices. Okay, on the next piece here, I have my picture and it tells me the wings of an SR-71 Blackbird aircraft suggest congruent triangles. So these two congruent. What is the measure of angle D? Remember, if I have congruent triangles, then all of their corresponding parts are also congruent. So these two angles are 30, which also means that that F would be 75 because these two are the same corresponding angle. So then I would just need to find A, which would correspond to angle D. So what I could do is I know all three angles in a triangle add up to 180, so I could take 180, subtract away 30 and 75, and then get my answer. So I know angle D is 75 because A is 75 and their corresponding parts. Alright, you're going to pause the video and try the got it question. So in the got it question, it says, suppose you have congruent triangles and angle W is 62 and angle Y is 35. What's the measure of angle V? Well, S and V are corresponding angles. So if you know what S is, you know that it's going to be congruent to V. So I went ahead and found what S is by subtracting 62 and 35 from 180. And so I got 83. And since S is 83, then I know that V is 83. It also asked me to explain, and so my explanation would just say by corresponding parts. Alright, example 3. It's asking me, are the triangles congruent? Justify your answer. So here are my two congruent triangles, here's my two triangles. What I've done is, in order for them to be congruent, all corresponding parts have to be congruent. So I have one set of angles, and I have another set of angles. So I have two pairs of angles. The next thing I would be asking is, do I know if these angles are congruent? And the answer is yes, which is why I marked them. And the reason they're congruent is because those are vertical angles. So all three sets of angles are congruent to another set over here. Now I'm going to look at my sides. AB is congruent to ED. That's marked by the tick marks. Then I also know that BC is congruent to CD. They didn't mark it with a tick mark, but they did label it with the same measurement, which is why I know they're congruent. Then I know AC is congruent to CE because they're both measured with 6, so they are also congruent. So since, and I listed out all of the corresponding sides and all the corresponding angles. So since all of those are going to be congruent to each other, I know they're going to be congruent triangles because corresponding parts are congruent. So my explanation would be explaining that these two angles are congruent by vertical angles. Then I would explain how these sides are congruent. So then I would say they're congruent by corresponding parts. Okay. On the last page here, you have a got it question at the top. See if you can decide if those are congruent or not. So one thing to note is I have an isosceles triangle, which means that in this big triangle I have two sides that are congruent. That means that my base angles would also be congruent. So that's why I marked A congruent to C. The other thing that you're going to want to start getting familiar with is the reflexive property. Notice that you have two small triangles in here and they share this side. So that means that BD would be congruent to itself because it's butting up against itself. There's not enough information here for me to decide if these angles are congruent or if these sides are congruent. So the answer in this would be no, because I don't know of any of if the other pair of sides or the pair of angles are congruent to each other. Okay, last piece in this first section is the third angles theorem. And it says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Should make sense. If I know this angle is congruent to there and that angle is congruent to this one, it would only make sense that the last angle would have to be congruent, having that same measurement. What you're going to find in chapter 4 is that there are proofs that are reappearing, but they're easier proofs. And the reason I say easier is because there's kind of a process that you have to go through. Let's take a look at this first one. When I'm setting up a proof, I hope by now you know that the first step is always writing down the given. Now the given doesn't always include just one statement, so make sure you write down every single statement that's in the given. Now, from there, I'm just trying to figure out why they told me what they did. I'm trying to show that these triangles are congruent. So if I'm going to show they're congruent, then obviously I'm going to want to show that all of the sides and the angles are congruent. So the first thing I wrote down was, I know that LN, this angle or this side there, is congruent to itself because that's going to be reflexive property, and you're going to use that quite often when you start going through these triangle proofs. So be aware whenever you have triangles that are butted up next to each other, that same side will always be congruent to itself. Okay, so now I have all three sides congruent, and I have two pairs of angles, so now I'm trying to decide if I know that these two angles are congruent. Well, by the previous theorem that we just went through, if I have two pairs of angles congruent to each other, the third angle has to be congruent to each other, and that's by the third angles theorem that we just talked about up here on this one, up theorem 4.1. Now I know that all my angles are congruent to each other, all of my sides are congruent to each other, so I can say that these triangles are congruent, and the reason I'm going to put it is because of definition of congruent figures. That's what you're talking about today. Definition of congruent figures means corresponding angles and corresponding sides are always congruent to each other. Okay, I know that's a lot of information on the first one, but it's setting you up to make sure that you understand corresponding parts, and then also we're going to start getting into proving triangles that are congruent.